student, in the chapter of haloalkanes and haloarenes. Today we will discuss SN2 reaction, SN2 reaction and their mechanism. Okay student, now discuss SN2 reaction. Dear student, SN2 reaction means here 2 stand for bimolecular and N for nucleophilic and S for substitution reaction. So we say that SN2 reaction is also known as bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution reaction is also known as, in shortly known as SN2 reaction. Okay student? Yes student, here a reaction is given. In this reaction, CH3CH2Cl, you know that CH3CH2Cl, the carbons which contain chlorine, that attached with chlorine, is joined with a single carbon. So it is known as 1 degree alkyl halides. 1 degree alkyl halides, dear student, 1 degree alkyl halide here. In this reaction, in presence of polar aprotic solvent, PAS means polar aprotic solvent. In presence of polar aprotic solvent, breaking of NaOH bond take place and form Na plus and OH minus. Okay, dear student, and the chlorine leave from the carbons. So it is also known as the leaving group. Chlorine is a leaving group and best leaving group, good leaving group, and leave from the carbons. When chlorine leave from the carbons, at the chlorine negative charge and at the carbon positive charge develop, and then OH minus attack on this carbon, because after the leaving of carbons, here electron deficiencies or electron density is decreased. Okay student, but always remember the attack of this OH minus is nucleophile. The attack of non-nucleophile as a OH minus is always opposite direction of the leaving group. Leaving group leaves from here, so attack from the back side of the leaving group. Okay student, after the attack from the back side the compound is formed, OH, then CH2, then CH3, and Na and Cl formed NaCl. Dear student, this reaction is exothermic reaction because in this reaction heat energy released. Okay, dear student, now discuss what is the mechanism of this reaction. Dear student, in this reaction, first important things, you remember that in SN2 reaction is one step reaction. SN2 reaction is one step reaction. SN2 reaction is one step reaction. Dear student, first thing is this reaction is single step reaction. And the rate of this reaction depend upon concentration of alkyl halide and concentration of nucleophile. The rate of reaction depend on the both concentration of alkyl halide and concentration of nucleophile, both. Okay, due to the rate of reaction depend upon the concentration of both, so order of reaction 2 and molecularity of reaction also 2. Molecularity of reaction 2 and order of reaction also 2, because here the concentration power 1, 2. Okay, due to second order reaction we say bimolecular reaction, because this is known as bimolecular reaction. It is because in this reaction concentration rate of reaction depend upon the concentration of reactant and concentration of attacking agent, that is nucleophile. Okay, dear students, SN2 reaction carried out in presence of a polar aprotic solvent, that is PAS. Here PAS means polar aprotic solvent. Always remember, SN2 reaction carried out in presence of polar aprotic solvent. Okay, when you write down SN2 reaction, always remember that to retain polar aprotic solvent. The reaction SN2 reaction carried out in presence of polar aprotic solvent. Okay, in SN2 reaction, pentavalent trigonal pyramidal transition state is formed. Dear students, when the reactions of alkyl halide and NaOH carried out, then the leaving group, that is known as chlorine is here a leaving group. It leaves from the carbons. When the chlorine leaves from here, electron density decrease at the carbon and electron density increase on the chlorine. But when chlorine leave from their site, simultaneously nucleophile attack to the carbon from the chlorine sleeve. But the attack of nucleophile opposite direction of the chlorines from the chlorine or any living group leave. Okay, here chlorine leave from right side, so attack from the left side. Okay student, if chlorine leave from left side, then attack from front. Okay, dear student, in SN2 reaction, leaving of chlorine means leaving group and attacking of nucleophile are take place in same time. When leaving of leaving group and attacking reagent take place in same time simultaneously, then the state is known as transition state. Dear student, here in this OH form OH by the attacking form new bond between the carbon and OH, and here chlorine leave from here and break their old bond. Breaking of old bond between carbon and chlorine take place and formation of new bond between nucleophile and carbon take place. Okay, but both situations are seen at the same time, at same timing. So this stage is known as transition state. Okay student, but the shape of the transition state, is pentavalent trigonal bipyramidal. So we say this transition state is the pentavalent trigonal bipyramidal. Okay, dear student, a state in which leaving group leave and nucleophile attack. Whenever nucleophile attack at antiposition of the leaving group. Okay student, always remember, nucleophile attack always antiposition of the leaving group, as like here. Okay, this is known as inversion. You observe here, chlorine joined at the right, but new bond formed is left. Okay, this is inversion. This is the inversion. Okay student, this is the inversion. Dear student, in SN2 reaction depend upon the steric hindrance. SN2 reaction depends upon the steric hindrance. What is the meaning of steric hindrance? Dear student, the methyl group or alkyl group's presence on the carbons which is tightly attached with halogen is create repulsion of electron, donate electron towards the carbon. This is known as steric hindrance. Dear student, less steric hindrance means less number of methyl group is favorable for SN2 reaction. So we say that a alkyl halide which contain the minimum number of alkyl is favorable for SN2 reaction. Okay, student. So here rate of SN2 reaction depend upon the steric hindrance. So you observe here the carbons which attach with chlorine attach with a single alkyl here, but here 2 alkyl group and here 3 alkyl groups are present. Dear student, you know that the SN2 reaction depends upon the steric hindrance and less number of steric hindrance created by alkyl group. Number of alkyl group is less than it is favorable for SN2 reaction. So we say that 1 degree alkyl halide which have the single alkyl group is more favorable for SN2 reaction and give SN2 fast as compared to 2 degree alkyl halide which contain 2 alkyl group and 3 degree alkyl halide which contain 3 alkyl groups. Dear student, here 3 degree alkyl halide have the more steric hindrance and 2 degree alkyl halide less and very less steric hindrance seen in the 1 degree alkyl halide. So we say that 1 degree alkyl halide is more favorable for the SN2 reaction. It gave SN2 very fast and it is because due to presence of single methyl group on the 1 degree alkyl halide, they have less steric hindrance. Okay, student. So we here take 1 degree alkyl halide. It is because they have the less steric hindrance, which is the favorable for SN2 reaction. Okay, student. Dear student, when chlorines leave from the site and OH join to the carbons, then a compound is formed. In this compound, OH attached at the anti-position of the chlorine. Okay, so this is known as inversion. This inversion also known as Walden inversion. Okay, dear student, this reaction as like the umbrella. In umbrella, you observe here like umbrella. The inversion is like umbrella. When you take umbrella and a storm is come, then your umbrella, shade of umbrella, cloth of umbrella goes to inversion. Okay, student, this is known as Walden inversion. Umbrella like here, but due to storm is it invert like here. Okay, this is known as Walden inversion. Dear student, SN2 reaction depend upon the ability of leaving group. The leaving group who leave easily give the fast SN2 reaction. Dear student, the ability of leaving group depend upon their size. The leaving group which have the larger size, they form longer bond, and the longer bond, the larger bond break easily, and therefore leaving group leave easily. Dear student, you know that the size of iodide is higher than the size of bromide, chloride and fluoride. So iodides from alkane leave easily as compared to bromide, chloride and fluoride. Dear student, always remember the leaving ability of fluoride is very less. So finally you take in your mind, it do not give the SN2 reaction. RF, alkyl fluoride, do not give SN2 reaction. SN2 reaction given by only RI, RBr and RCl, and RI give the very fast SN2 reaction because due to ability of leaving group like iodine. Okay student? Dear student, now discuss RH bond. RH bond means bond between alkyl group carbons and halides is known as RH bond. Breaking step is RDS of the reaction. RDS means rate determination step. RDS means rate determination. The step in which RH bond is break is known as RDS of the reaction, that is rate determination step. Dear student, here breaking of bond take place, breaking of bond between the C and X take place, so we say that it is the RDS of reaction, which means rate determination step of the reaction. Okay student? Dear student, some key point keep in your mind. First is the rate of reaction. The rate of reaction is directly proportional to electron withdrawing group. EWG means electron withdrawing group. What is the electron withdrawing group means? Electron withdrawing capacity means the capacity of pulling electron. The capacity of pulling electron is known as electron withdrawing. And nucleophilicity and ability of nucleophile. Nucleophilicity means ability of nucleophile and inversely proportional to steric hindrance. Dear student, always remember steric hindrance is not favorable for SN2 reaction. Like here, in 3-degree alkyl halide have the highest steric hindrance, so it is not favorable for SN2 reaction. But in 1-degree alkyl halide have less steric hindrance, so it is favorable for SN2 reaction. So finally we conclude that SN2 reaction carried out in presence of polar aprotic solvent and 1-degree alkyl halide. Okay student? And in this reaction Walden inversion take place because the attack of nucleophile is anti-collision of the leaving group. Dear student, take a screenshot of the given content on whiteboard, and in next lecture we will discuss unimolecular substitution reaction, that is known as SN1 reaction. Okay student, thank you very much.